Hi, everybody. Sorry. I too have a cold and also understand, yes, absolutely where you're coming from. I'm going to Big Data London tomorrow and I've got about 16 certificates I have to show before I walk in through the door. So who am I? Thinner or fatter after COVID? I think probably fatter. So my name is Peter Marshall. I'm a technology evangelist working with a company called Imply. I did lots of stuff for a long period of time, and I've got a degree in theology, but don't ask me any questions about God. I'm TOGAF certified, sounds like I should be in an institution. And if anybody has a Peloton, I'm on there. Any Pelotoners? Wrong audience. Yes, I had COVID, and it was really fun. If anybody wants to ask me any questions, there's an email address. And I'm Peter Marshall IO on Twitter, and I even have Racket, if anybody's heard of Racket, this new thing. It's quite cool. Anyway, so thank you, everybody, and thank you, organisers, and thank you, organisation. I am here to give you a wave from another Apache project called Apache Druid. Has anybody heard of Apache Druid? Excellent. Good. It's quite tricky to place Druid. We're still, as a community, trying to work out how we explain what the Apache Druid database is for. So this is our latest set of slides attempting to do that. So if it works, let me know. And if it doesn't, I'm not interested. But no, tell me if it works. And the way we try and explain how it works is by describing hot and cold data flows. And particularly, because I'm talking to you, what I'm going to lay out is what I think are the important things that have to happen before you put data into Apache Druid. And we've done a bit of a study over the last year, particularly focusing on clickstream data, with a little bit of IoT thrown in just for a laugh, to kind of highlight exactly why you have to do stuff before you put it into Druid. I've said that twice now, haven't I? So I might say that 3 times. So yeah, I'm going to talk about why streaming is important, why stream processing is important, why processing is important, and then give you an indicator about where to download Druid and play for it. There are t-shirts over there. Please take all of them because I don't want them anymore. And there should be some stickers in the bag as well. So please help yourself to all that swag. So here we go. First presentation in 3 years. So Druid is about 10 years old. This is Gorse. If anybody hasn't used Gorse to visualize their Git commits, oh my God, go do it. It's awesome. It was open sourced in about 2012. It incubated through 2018-19. It became a top-level project in 2020. 300 contributors all over the world. Very active project. I'm very proud to be part of the community team. And working with the engineers that are writing this stuff, because I believe, because I would, that it's genuinely changed how people make decisions, whether that's you and me as engineers or whether it's someone in business. It's used by people who are looking at risk and liquidity in the banking markets in Turkey. It's used by people who are using IoT data to work out whether the bee colonies are collapsing across Europe. It's used to find out whether the world's largest data centers are about to explode. It's used by Netflix to make sure that Stranger Things is going to stream properly next week, whenever it's coming out. So it's used by a huge number of people. I'm going to try and explain why they use it. It's all about speeding up decision making. It's about very, very fast query times on data. And it's about opening up that data to lots and lots of people. This is updated in the hotel before I got here. Some information about what Druid has done. All I want you to take away from this is really that there's lots and lots of activity in the community. 0.22, for those of you who know about Druid, is coming out hopefully next week. And some of the improvements are really, really cool. It's a very, very fast-moving project. If you guys know what vectorization is, vectorization support in Druid was introduced around about here somewhere, and we've now introduced vectorization as a community on data sketches, which, if you don't know what Apache data sketches are, allow you to do approximation on count distinct set operations and percentiles. And vectorizing that is going to be, well, awesome. It's going to make query times even faster. And I'm going to keep saying query times even faster because that's what Druid is here to help you do. Bit of history about where Druid came from. So Druid was open sourced in 2012 by a company called MetaMarkets, who were acquired by Snap, as in Snapchat. They are an advertising exchange. Does anybody work in an advertising exchange here today? So advertising exchanges, basically, there is a place where people can advertise stuff, and the publishers, people like Facebook, etc., and they bid on that space, and when you and I go and click on something, that's called the click-through, and it's all about making sure that someone has the right ad in front of them so they click on it. And it's extremely competitive, very, very competitive market. So what MetaMarkets wanted to do was to prove that what they were doing was right. They wanted to prove that they had got the right advertising space, that they were offering it at the right price, that they were delivering things effectively. But their problem was their success, because the volumes of data are massive, as you can imagine in advertising, billions of events a day, a second sometimes. And what they were faced with their pipeline, if you take yourself back to 2012, those of you who were born before 2012, you've got quite an unscalable, disjointed architecture, where all of the products that they were using were very limiting in terms of what they could build for the end user. That's the focus. And those of you who know about streaming technologies will know if you don't use streaming technologies, you do end up with very high latency from the point it's being produced to the point it's actually consumed by the end user. So like any sensible person, what they decided to do after a full review was to just write a new database. And that new database that they created was called Druid at the time, but it then became Apache Druid. What is it for? As you'll see on the t-shirts and on the website, it's labeled as a high-performance real-time analytics database. The point of it is to give end users an interface that is full of very fresh data, where the data arrives extremely quickly, so it's the latest data, but also enables them to have more dimensions than they've had before and have that data at a higher granularity than they've had before. So it was quite a difficult thing to build, as you can imagine, which is why we have some serious members of the community. So this is the UI that they built. The idea is that the end user can pick one of 30 dimensions. It's actually quite an old example of the UIs that you get for Druid now, but 30 different dimensions, and all the queries that are executed by this UI execute in under a second. So I've seen them like 0.1 second, these queries are executed. That's the point of Druid, is to enable someone to say, I want this dimension, I want to filter by this, I want to group by that, I want to do whatever aggregate. And there's no cube being created at all before it hits Druid, which is quite cool. And the first people after it was open source to adopt Druid were Netflix by 2015, when the first project committee, before it was an Apache committee, met. It was eBay, PayPal, Cisco, Yahoo, and then others. So that's my logo slide. I hope you like my logo slide. Tim Tully was the Vice President of Engineering at Yahoo at the time when he said this about Druid. And I want to highlight three particular things about what he said to introduce you to what Druid is for. First of all, that it's about OLAP-style processing. The thing that Druid does extremely well is statistical calculations. So averages, mins, max, all that jazz that I failed at GCSE maths. And it does it on the fly, as I say, so there's no cube, there's no pre-calculation. So it's about getting answers to statistical questions for your UI as quickly as possible on billions and billions. Well, we're not all Yahoo. It's linearly scalable, so you don't have to have billions of events. You can just run it on your laptop if you want, but it's very scalable. So what does Druid do? Druid is not really anything new, although it is new. It's really learning from what the advertising exchanges built for us historically anyway. So it's learning about things like using good ingestion technique to scale linearly at ingestion time. It learns that from log search. Don't have a fixed schema, learn that from log search. Let's enable text searching, learn that from log search. What else should we learn when we're building this database? Let's make it a time series database, because all decisions in business have time as a dimension now, and if they don't, why are you in business? This low latency ingestion. We need time-based functions so we can compare what happened today to what happened 6 months ago, and we need to be able to have good time-based functions in there. And thirdly, use a columnar database. For heaven's sake, don't put things into SQL Server anymore. So we need to be very efficient with our storage. We need to have secondary indexes. For those of us who have been around a while, that's not new. But obviously, we need secondary indexes, and we need to execute all the queries in a distributed fashion and scale out the distribution of those queries and have them execute in parallel. So what you end up with is a very mature and scalable ingestion capability, many millions of events per second if you need to. Typically, just FYI, it's about 10,000 to 50,000 events per second per thread. So you can scale up quite significantly. You have optimization, you have a distributed query engine that enables you to do these analytics on the fly in sub-second speeds, and again, not fixed by a cube. And then finally, this really optimized, very refined query database itself, which has all these optimizations inside it. So why do I need that precisely? So this is a slide from my boss. So this is a really good slide. This is the best slide anyone's ever created. We have, it's American, by the way. We have cheesy Cheetos, which are very, very hot, the kind that get yellow on your fingers. And we have cold use cases. Government cheese, as Rachel Podresky, my boss, describes it, as you can see, is in black and white to prove that it's cold data. So let's focus first of all on the cold data use cases. So cold data use cases, what we say are those where we're not really that bothered about how quickly the queries execute. I mean, we are bothered, but we're not interested in them happening in under a second. We want those queries that could last 5 minutes, they could last an hour, they could last a day if we really wanted to, because what we're powering here is like standardized reporting, not a UI that's highly flexible. Because we're building out that kind of experience, we probably have a team of people who are kind of fronting that. And they're going to just take in these requests, they're going to work out what the end user actually meant, and then they're going to produce something and query that, and then produce the end result for them. And that means we're not going to have lots of users in this database. We might just have a team of 10 or 20 people using it, because it's all about reporting or planning. It's not about interactivity. It's not about offering a user experience to my customer on a mobile app. This is just your standard, what I grew up with, kind of experience. On the other hand, the hot use cases, they're all about data being fresh. They're all about data that's from the last few hours, maybe even the last few minutes. And therefore, we need the query to execute now. Otherwise, if you wait an hour, you might as well have not streamed it in, had you? So it needs to execute really quickly on the freshest data. And while we're there, let's make sure that as many people as possible can access it. Don't just lock it away. And finally, we're going to build a user interface which is friendly and user-focused. So this is really where Druid lives. It wants to be aiming to do these, not these. So just to be clear, I'm not saying that no one should use these databases anymore, because that's silly. What I'm really saying is that if you want to have this kind of pipeline, it requires a different kind of database. So some examples of use cases where Druid is implemented and deployed. Risk and fraud analytics, where we need to get lots of data as quickly as possible, and we need to understand it and slice it and dice it. And people might ask questions that they haven't asked before. Data-driven applications, embedding in websites and mobile apps, network performance monitoring, network operations centers, clickstream, digital advertising, the thing that everybody loves to hate. Even small digital advertising companies have huge amounts of data. That's where Druid came from. So it's kind of been, if you like, stress tested there. All of these are places where we need to scale the ingestion, we need to scale the number of end users, and we need to scale the flexibility of the products that actually get delivered. So, as a hot database, what's it for? Making analytics personal, interactive, and intuitive, allowing people to adapt in their business very quickly, giving people live and historical data, and expanding the audience. Why? Gen Z. Gartner quote. I guess because, yeah, I'm old now. But like this has happened, gone are the times where I have to submit a report request to find out what the energy usage was on my electricity meter. I don't do that anymore. I can't ring over and say, hello, please. Can I have these fields, please? That doesn't happen. So what do people generally put on the front of Druid? Grafana, Looker, Tableau, Metabase, Superset. These have got great integrations. In fact, there's lots of videos about Superset being integrated with Druid. If you want to develop stuff, people are developing stuff with React and Angular. There is a company just down the road from here who have an Elixir series of APIs on the front. And if you're using data science, people are using it as an additional database for rapid investigation of data, as opposed to like the long-term stuff. So I guess testing the theory early. What kind of user interfaces are people building? The point here is that the user interface that people build on top of Druid is personalized, it's very flexible, it's built using extremely quick queries. I wrote a blog post about it. If anyone wants to go and read my blog, then that's cool. So this is a tool that Imply produce. It's called Pivot. You can see the point of this UI is dragging and dropping the fields, selecting whatever measures somebody wants and allowing them to edit them without anybody being told off. Lots of different visualizations. The idea is it's supposed to be fun and friendly and fast. Oh, did I mention I've written a blog post? This is my blog post, and it's just kind of got some qualities of all the things, whether it's Target or Netflix or whoever it is that's written their user interface on top of Druid. I've tried to summarize them to give you a bit of an idea about what it's for. So, Druid is for these hot use cases. Let's look at some examples. Oh, first of all, an unsplashed photograph I have attributed appropriately. This is a geyser, for people who don't know. What I try and think about when I think about these pipelines is that we are trying to build things that are extremely hot. And that means that we need this user interface, which is very hot, we've talked about already, but I also need to have a database that's built for purpose to do that. I need to have a database that allows flexibility, lots of scale, lots of good APIs, good retention policies, the ability to parallelize, and that optimizes the data specifically to create these things. And underneath that, the data itself needs to be hot. So now we come to the hello and the handshake. Because there is, yes, you could put your data in a lake. You could put your water in a lake and put that into a geyser. Of course you could do that, but it's not as exciting as just filling it with data that's now and doing some processing on it now. Because otherwise, what you've done is you've created this wonderful investment in things like Kafka, and then you've chucked all the data into something, and then you leave it there. Someone goes to sleep, they wake up in the morning, think about it again. You haven't allowed people to actually make decisions on it. But we all know that you still need to process that data. You still need to do something to it to make it real and relevant. Where does Druid fit in a pipeline? Druid is described as a query accelerator. Fanjin Yang, who was one of the original members of the original development team for Druid, he's our CEO, describes Druid as, well, basically he says it's a query accelerator. It sits after the data lake or message bus. It provides the analytics engine for sub-second calculations on real-time and historical data. So I plug it into that stuff for the end user, but my sources can be MySQL or Postgres, Hadoop, S3, Azure, GCS, etc. But the fun, the cool things, the geezers come when we plug it into Kafka and Kinesis, and hopefully Pulsar soon. But we still need to do processing here. You've still got to do stuff with it. What kind of stuff are we talking about? So this is a good article to go and have a look at. It describes a full architecture where they have, look, Beam! Where they're using Flink to do processing after a bit of NiFi and Kafka jiggery-pokery. Druid is sat there with some data science stuff on the other side. That's a really good paper, actually, to go and have a good read about where Druid fits. This is lifts. Yes? No, Netflix. This is the Netflix pipeline. So they're using Flink at this point here. I don't know if they've got used Beam in this here. But notice this line, direct from Kafka into Druid. That means that people are reading directly from a Kafka stream, and then they're running queries on that data live and doing exploration on that data. There's no data cube being created along here. But they also have Trino in there. And that's because Trino is in the slower lane. It's not in a bad lane. Just say that again. It's just in a different lane where we don't worry about queries taking so long. And the processing might be different. The view of the data that people are looking at might be different. And then something called Spark. Don't know what that is. Then we've got this Virtual Druid Summit talk by Lyft. Lyft is like an Uber competitor in North America, for those who don't know. And they've got a really good talk. This is their pipeline. So again, they have a squirrel doing processing here. But notice how they've kind of bifurcated. And this is very common for Druid implementations, again, because it's about which lane you want things to be put into. So here, they're doing transformations of the underlying data format. That's just one reason you might want to use a processor. And again, you don't have to use Presto. Surprise. You could use something else if you wanted to. If you are interested in knowing a particular technology being used with Druid, if you go onto the Druid forum, there's a new thing at the top right-hand corner in the burger, which is the Tag Explorer, and you can go and have a look in there and just click on something obscure like Iceberg and find out where Druid is being used by things like Iceberg. And we have keeping an eye out for all the Beam stuff, and we're adding that as we're putting in there. But also you see Flink and Spark and a few others as well. So, why do I think you might need to use, you can tell me the answer to this question, I might be completely wrong, but why do I think you need to have something upstream of Druid that is controlled by something like Beam? So you might have to have different data sets for different use cases. And this is different to a data lake approach where you kind of stick everything in and a query engine just goes and gets specifically what you want and presents it to the user. That's fine in a kind of a cooler use case. What we have are some examples of where people say, okay, I'm going to provide these 15 dimensions from Kafka, and I'm going to get them in front of people as quickly as possible. And upstream, I'm going to put some basic kind of algorithm that enriches the data and tells them whether or not that transaction is fraudulent. And I need that to get there now. So you'll have that data stream coming in. But then you might have one that's a bit broader, where you don't have that information. Something that's a bit more reliable. Maybe it's where you've had to do some more enrichment that's a bit more complicated, and that might go into Druid in a different stream, in a different data source. You can still union them. But the use cases are different. Maybe you'll do some calculations upstream that are particularly stable. So a really daft but useful example of that. So I've got Raspberry Pis. Love Raspberry Pis. I've got that little sensor unit that sits on the top and it reads it in Celsius. Well, it turns out actually it reads it in Celsius plus or minus whatever the heat of the chip is on the Raspberry Pi. So you have to do some change in the calculation. And then actually I wanted it in Fahrenheit because I don't know why. So why would you do that at query time? You don't need to do it at query time. If it's in the stream, do it beforehand. It's techniques that enable the queries to execute that much quicker than they would if you were doing them over and over again. Remember, we're talking about tens of thousands of concurrent users in the case of people like Twitter. Then we've got short and long sources. I've seen some horrible times when people have just presented all of the data to end users when they know that 95% of the filters always take out 90% of the data. We're talking billions of events. That's not a really good thing to do. So maybe you will filter things, or you'll use some complex filters and upfront load those. You might split them because you've got different retention periods. Who knows about data sketches? If you don't know about data sketches, I would say it's probably one of the most important inventions in computer science in the last 4.8 billion years, and that's a long time. So I'd definitely go and have a read about those for approximation at speed, and the optimizations are ridiculous. They are a natural thing supported since one of the first releases of Druid, actually. You might need to denormalize things, you might need to enrich things upstream, because again, do you need to do that at query time over and over again? Probably not. Druid enables you to do windowing. So what we can do at ingestion time is you can do something called rollup, which truncates the timestamp actually. And then does a group by, so you can generate metrics based around particular periods of time. If you need to do anything more complicated than that, you probably need to do it upstream. And then, bane of my life, state engines. So what Druid will do is it will allow you to do updates, but it allows you to do updates on periods of time. It doesn't do row level updates particularly brilliantly, unless you're very clever. So if you have something where you need to update rows, then you might need to do something else, like emit deltas of things. But if you want to know about that, come and talk to me about that afterwards. Cool. If you want to know more, come and talk to me. You can download it and do the quick start. There's something called GitHub, and there's the Druid user forum. I'm always on there. There's more meetups sponsored by Imply. It's a professionals group on LinkedIn. Follow us on Twitter, and there's an ASF Slack channel, #Druid, and also you can speak to us on Google User Groups. I hope that was okay. Thank you. Any questions? All right. Okay, grilling. Any questions, anybody? Yes?
Is there like a managed service offering?
Oh, what, like from a company like Imply?
Oh, sorry.
I was asked the question, right? I've got to ask. So, yeah. Yeah. There are several. Imply has one. We have tooling that allows you to spin up the clusters. That can be quite tricky. Kubernetes is like fully supported, or it's being improved within Druid. There's a Druid operator that Splunk have recently contributed that's very cool. It's worth having a look at. But yeah, we have managed offerings that enables you to do the setup of the cluster. You also need to think about the monitoring of Druid. I don't know why, but it is important that you think about how you're going to monitor these distributed systems. It's a fully distributed application, so you need to treat it as such and monitor it. So yes, we have a monitoring tool that enables you to do that. Some people will use things like Grafana or some other homegrown solution to monitor it. Yeah.
Is the managed service on AWS, GCP, or your cloud?
It's available on AWS, GCP. Microsoft have one, do they? I think Azure. Yeah, it's multi-cloud, and that's just because Druid itself is just a bunch of Java processes, basically. So as long as you've got a Linux kind of environment, you can spin it up there. Yeah. Yes.
Let's say I convince my CTO tomorrow to try it out. I deploy it on Kubernetes. What is kind of the cluster size you will need?
So,
Certain use case.
okay, so Druid Sizing is a talk in itself. So there are 3 families of processes in Druid that you do need to be aware of. So you have a process called the sorry, talking to actual real people has thrown me completely. So you have the master services. They're called the overlord and the coordinator, and you need a quorum of those essentially to make sure you don't have one arguing with the other, and it allows you to do rolling upgrades and things. You don't need a big machine for that. M3 large is usually okay if you know the AWS stuff. The historicals are the bit where the actual data is stored live for query. So just to thank you for that. Druid is a database, so it takes a copy of the data. So it's not reading it from the lake and processing it. It's taking a copy that's optimized and then running it from there. And that data is copied out of something like S3 or whatever and into these servers. So you need as many historical servers as you have data times your replication factor. That's the first thing for the storage. And then the more cores you give it, the more data it's able to process succinctly. at once when the queries execute. So that's what makes it linearly scalable, because if you have more time that you want to query, being specific, then that means you're going to probably need more cores, and you'll have more data, therefore you'll have more historicals. Then the ingestion is handled by a process called the middle manager at the moment, and the middle manager scales according to the number of events you want to ingest and however complicated the ingestion process is. So they're separated processes. And then the queries are handled by a fanning out and a fanning in process, handled by a process called the broker. You only need one of those, really. But then the queries execute on both the middle manager in the historical processes, the middle manager for real-time streaming and the historical for historical data. So it's kind of like they are separately scalable. So the answer to your question is, it depends. That's what the answer is. But yeah, you can run it on a MacBook if you want, or 4 Raspberry Pis, which is what I've got at home. Any other questions? Yes.
My question is, so when you mentioned the processing is done upstream, do you have to predefine that? Like, what type of?
So I'll give you an example of a complicated one that needs to be done upstream. And this is to remember that Druid's job is to execute queries very quickly. That's what everybody in the community is trying to get it to do. Every enhancement is about optimizing query execution. Sessionization is something that takes time to understand, where you might have rules that say, okay, the session doesn't end until the last activity was, say, 30 minutes ago. Or if you're doing something like Hulu do, which can get very complicated understanding when sessions finish. That really has to be defined. All the rules about how you understand what a session is needs to be done upstream, ideally, and therefore you need to manage that separately. So in that particular use case, I would tend to be saying it needs to be upstream. The interesting thing is with Druid, as I say about these queries needing to be executed really quickly, you could probably do a series of complicated queries that execute to work out sessionization of data. You can work out the sessions at query time, right? But you end up with tons of subqueries, and you have to ask the question, if what I'm trying to do is to build an end user interface where the response is like that, why would I execute that at query time? That's essentially the rule, right? So if you've got business rules, you've got particular logic, you need to define that outside of Druid upstream. You can do an amount of transformation at ingestion time in Druid. It's quite a flexible thing. You can even do JavaScript at ingestion time with Druid. So you can do bits of it. But yeah, definitely the complicated things you need to do upstream. Does that answer your question? Yes. Oh.
Flink has a kind of window, or is inventing a kind of window that few releases. How does Druid come to that? Is it the difference? Is the columnar store?
So I don't know the answer to that question. What I can tell you is that how can I put it? If you look at something like KSQL, which is executing on the Kafka stream, it's doing that, as I understand it, as a separate kind of processor that's watching and created another stream, as I understand it. With Druid, that windowing happens at ingestion time, and it's very specifically, it's looking at, say, 10 minutes, then another 10 minutes, then another 10 minutes, then another 10 minutes. And it's outputting aggregates at those intervals about that 10 minutes worth of data. So it's a very specific, it's a very important optimization technique in Druid implementations, actually. But that is what Druid does. If you want to do lead and lag, because Druid's queries are parallelized, it means that it's very difficult for Druid to do lead and lag because it can't find out where the previous row was. Does that make sense? So there are some certain windowing stuff you need to do before it hits Druid. And therefore, I would suggest something like Flink is trying to do, something like Kafka does, you would have to do that upstream. If that answers your question? Okay, good. Yes?
And what's the query language? Is it like SQL-like?
It is, yeah.
Okay, SQL Server does have a console on it.
Oh, yes, sorry, yes. I was being facetious.
Come on.
Yeah, so Druid's original query language is JSON, but SQL is done through an Apache calcite interpreter, which is why you've got so many good enhancements over the last few years, and why people just wake up in the morning and go, oh, maybe we should have standard deviation. So they'll put that into the calcite interpreter. But yeah.
I played a little bit around with Pinot, and I understand they're kind of in the same space. Where would you put each or highlights from the Druid compared to Pinot?
So you get so federated data sources, for example, isn't something that Druid queries Druid, right? Pinot is doing the execution of the query by pulling it. So, for example, the schema doesn't have to be defined up front when you're using Pinot. Right? You can just decide I want a different schema today. With Druid, you're defining it up front in the ingestion specification, saying I want these dimensions. It's not fixed, but you are defining that up front. So it's different. It's different use cases, I guess I would say. That makes sense. That as well as them being architecturally different. And Druid is making a copy of its data, which Pinot doesn't do, as far as I understand. I have to caveat all of that because I'm on camera, from what I've read.
Very good question. So I know some IoT database, they try to optimize for performance. They limit that the time series data must be sequential. Does Druid have this limitation?
No, it doesn't have to be. So if I understand your question correctly, see what I did there. So no, data can be out of order when it arrives into Druid, and that can cause problems with how Druid stores its data in the underlying deep storage. So there's a process called compaction, and there's also automatic compaction that basically defrags the database if stuff arrives out of order or late, which happens a lot in IoT and mobile phones. Masts stuff.
Yeah, I
Yes.
just had a quick question similar to Matthias's. Could you compare and contrast it with Elasticsearch for like storage and doing these statistical calculations?
Yeah, so do you want the party line or do you want mine? So Druid, when I've seen Druid being compared with Elastic, one of the places where Druid struggles is on something like I have 5 million log entries and I'm looking for the word orange and I want to find the word orange. And so Druid doesn't have like complicated search indexes on each column. It doesn't have anything like that. It's not a naive search thing in there at the minute in Apache Druid. Whereas Druid's ability to do on-the-fly aggregations is way, way faster than Elastic. So what I'll see people have both because they want to search for the transactions, but then they also want to do extremely fast aggregates. Again, another place where the processor upstream is important to create the appropriate data types for each database. And where I've seen people swap one for the other is where the use case is just that different. And really what they're trying to do is what I was trying to do with Elastic when actually I was looking at things like how many 401 errors were there last month compared to this month. And they were using Elastic for the wrong thing. And where they might be using Druid for the wrong thing, for that matter. Yeah. Sorry. Thank you.